Okay, so as far as quantum physics goes, and as far as dark energy, dark matter, and dark flow, if dark flow does exist, if we're supposed to believe that the universe is infinite and everything's made of energy and everything can't be destroyed, then it actually kind of makes sense to say that as far as subatomic particles go, there's something that even makes up those. So basically, if we're to say that dark matter, dark energy, and dark flow are like the most common things as of right now that we know of, but then at the same time, though, we think about in the universe, maybe it's very possible that maybe there's things that make up those things could actually outweigh and outnumber, even though they're smaller, those would be the most common things in the universe. So is it possible, like as of right now, like the smallest known object that we know of are quarks. I think I'm spelling that right. You have like quartz, and then you would have before it was planks. So basically, what ends up happening is, these things are really small. You would need like obviously a really powerful telescope or a microscope to be able to see these things. And, the scientists that even discovered this, I can only imagine how type the precision would have to be to really be able to magnify such a thing. But anyways, it's very possible that even those things might very well, might not even be the smallest thing. But as of right now, that is what we know. So, is it possible that the smaller an object is, the more common it is in the universe, due to how small it is and everything makes up that? So, basically, and if people want proof, aside from, energy you can keep dividing energy, they say that quartz can't be divided, they can't be split. Maybe not yet. Again, keep in mind, people said the same thing about an atom, but they found a way to do that. So, science is always changing. That is a very universal law about science. So if the universe is made up of mostly dark matter, dark energy, and dark flow, and other sort of material, it's very possible that, if everything's made up of something else, you basically would have that material, because it's like everything, because as far as atoms go and as far as subatomic particles go, it's like a prime number, sort of. You divide it and you just keep going. But the thing is, though, your numbers don't ever have to end. Numbers are universal, and that's a proven fact. We just got to figure out the formula and just keep, and according to scientists that have been able to make sense of it so far, they have stated that, energy does multiply. I mean, even the closest thing that we can think of is like matter and antimatter collide, and it, like, what they call annihilates the form, but it just turns it into something else, and it doesn't truly truly erase it from history. It's just a chemical change, and it turns into something else. Radiation, good example. Quarks or quasars and gamma rays. You'd be surprised, like, what's out there. So as the universe expands itself, from what we've seen so far, and I do believe in, it doesn't have to necessarily be infinite, and that energy goes somewhere else, it's very and the fact that we don't know everything, that's another thing. So that's proof right there that there's got to be more out there that's even smaller than what we can see. Because again, we still haven't, because even if you want to be one of those scientists that tries to figure out the smallest known thing known to mankind or the largest thing known to mankind, I mean, there's a lot of ordeals that you have to pass through, and even a large telescope can very well prove useful. I mean, there have been scientists that, if you think about, like, most discoveries were discovered totally by accident. They were looking for something else, you could be out in the universe right now, like, looking for, like, a galaxy somewhere in a certain distance, and you might discover another planet totally by accident. And, or maybe a meteorite, or, a foreign object from another solar system. Another solar system meaning, like, it came from, like, another star planet, another planetary orbit of some kind, out of our orbit, for example, from another star system. It'd be, it'd be interesting. Everything in the universe is moving fast. The galaxy's moving, planets are moving, stars are moving, the stuff between them is moving. It's interesting, and it's all how many different forces exist in space. Dark matter, I believe even dark matter moves like, what is it, like 171 feet like every second? Or is it 177 feet? So somewhere around there. It's actually pretty cool, actually, to think that, and I always thought this was interesting, the fact that, you know, dark matter could be on this planet right now because the Earth is pushing itself into the universe. You know, everything's traveling so fast, but maybe the Earth is pushing radiation into its atmosphere because of its gravity and its magnet field and acceleration. You know, because when you push an object into something, it's colliding with it somehow. And usually the light particles either go around it or it goes right into it. So that's actually something to think about. Same thing with these quarks and all that. You know, these, where you would find them and what they do, it's very interesting. They might be very small, but they could move very, very fast if given the right predicament. There has definitely been some subatomic particles that are still theorized to exist, that scientists claim exist, but like they say there's not enough evidence for it because they're just either so rare or they move so fast that it might even move faster than the speed of light. And that we've already proven it with gravity, you know, with a black hole, because light particles can't escape. It just grabs the lightest things and throws them into, like, you know, another dimension somewhere. And that's been proven because black holes are so dark, you know, light doesn't implement with it because it just travels so fast. That's one way. And the pressure doesn't necessitate with it. So, you know, what do quarks do? You know, quarks. You know, we still gotta look into this a little bit more, but I do feel like we will figure it out as time goes on, as long as we have like a base model to go off of. You know, if we can figure out what exactly its physical properties are, and, you know, as far as chemistry goes, I mean, if we can identify, like, you know, what kind of element it is, even though it would probably just be a different classification, I do believe we'll figure it out as time goes on, though. I mean, you know, you just need something to sample, you know, write a bunch of research down and, you know, identify it. And if you could figure it out, then, well, you're definitely going to get some kind of reward for it somehow. So that'll be cool once that information comes out. But yeah, anyways, so yeah, basically subatomic particles are like, there's so many of them, and right now we know of like 17 of them, but there's probably a lot more than that. And I remember there was an old saying somebody once had where, like, if you know, for every subatomic particle, there's an infinite number of universes. And I've actually, you know, it's really interesting to think about. Everything is made up of something else, and it could be coexisting somewhere else, you know. Like your body, for example, is another good example of a infinite universe of bacteria and unknown diseases, or maybe not even just that, but good diseases, or, you know, it's an ecosystem of some kind, you know, and it really does make you wonder what else is out there, just waiting to be discovered in the long run, because there's so much we don't know, and at the same time there's so much we don't see. But again, when you start crossing into other dimensions and other, you know, it starts to get more strange and weird because you're trying to perceive that reality. What's out there, waiting to be discovered, you know. I mean, how much life would be different if we could just travel to another planet and just land on its atmosphere? You know, and I'm not just talking about rovers and machines, you know, because they've already done that with Mars and Venus. And I've always said that, you know, one of the biggest problems that we have with, you know, landing on, like, for example, like a telescope that you can see like the surface of another planet, you still would be surprised that even if they try to land like on the surface of that planet, would be a whole different story. It's hard to see the surface of something with an atmosphere from outer space directly down, unless you got something really caught up into its atmosphere or its orbit, you know. But you have to be careful because some planets, like, you know, like Jupiter and even Saturn, you know, for example, are really hard to really figure out because they're like so big, but their gravity crashes, or, you know, even the magnet fields crash the, you know, you can't really see what's on there because you can only get so far before you lose a signal, and the machine's already been ruined by the intense force in the space-time continuum. So, you know, quarks, whatever they hold in the universe, you know, small subatomic particle that holds even larger objects together. It's interesting indeed to think, like, you know, there really can be an infinite number of probabilities that we have yet to discover ourselves and what it leads us on to. I think, if you ask me, and I said it before, and I'll keep saying it, you know, I think life is progress. You know, if we enjoy what we see and enjoy what we do, we just keep going, you know. And that'll never change because we still exist. One way or another, we might say we die and that's the end of it, but at the end of the day, we may very well be surprised that the universe really doesn't allow such thing as death. Maybe death is just like some kind of an event. You know, we get reincarnated somehow, or we go to like another dimension or something like that. Whether you're physical energy or you're conscious, but it really does make you think the more things that we don't know, what exists that we don't see, because I think about it every day. All the things we don't see, all the things we don't know that exist right now. Again, Carl Sagan once said, somewhere something incredible is waiting to be known. And just because we don't have, and like Christopher Hitchens even once said, you know, just because we don't have evidence for something now doesn't mean that there's not evidence out there later on, or even right now. You know, it's just we haven't found it yet. And that is something to think about as far as science goes. There's so many discoveries waiting to be known right now that we have the technology. We just gotta get the right people in the right place at the right time somewhere. As Walt Disney would say. It's a matter of, you know, follow your dreams and do it, you know, somehow. So that's cool. So anyways, subscribe if you're not already. And if I find any more information, I'll let you know.